All right, second section that we're dealing with here is perfect squares, perfect cubes, and their roots. So we're going to learn how to do square root things and cube root things that are perfect squares and perfect cubes. The first thing, part of the outcome, is to have a decent understanding of what the first 15 numbers are squared. So if we go through the list, and you can do this at your own pace, if you have these in your brain, don't worry about it, but I would have some sort of concrete thing that you can look at to have these numbers at least decently memorized or be able to have kind of a pattern for yourself. And I would recommend to at least 13, 14 and 15 aren't ones that you're going to use as often, but they are nice to have in the back pocket just in case. So a lot of these, like I have up to 12 for sure cased. 13 sometimes gives me a little bit of trouble. And 14 and 15 are ones that, like I said, we don't use very often, but they are nice to have. And it's kind of cool because 13 and 14 squared are pretty much the same thing. And 15 squared is 225. So have this written down, have this ready to go. The square root of number n is denoted as just the square root sign of n. And n in square roots, for now, as we understand it in grade 10 math, must be positive. At some point in grade 12, university, you will be allowed to take the square root of negative numbers. For now, we are not allowed to do that. It does not work. You don't know how to do it. If we're determining the square root of a whole number without a calculator, we need to write out the prime factorization of the number. We need to highlight the pairs of numbers, and it must be a pair. We need to simplify the highlighted pairs, and that will be the square root value. Now, I say we have to do it without a calculator because we need to know how to do it. It's part of prime factorization like we did in the last section, sorry. You can use your calculator to check your answer, though. 100% valid, good way to do it. So 1,296 breaks down into 3 multiplied by 432, 3 and 144, 12 and 12, and then I'm going to write this as 2 squared multiplied by 3, because that extra 4 step is just, it's not very useful to me. If you need to write out 4 breaks down 2 into 2, do it. Represent it how you need to represent it. So then if I write this out, not in prime factorization, but just in a list of factors might be more appropriate for what we're doing here. We can see quite easily that we have a pair here, a pair here, and a pair here, and a pair here. If I was looking at it in terms of prime factorization, this would be 2 to the 4 multiplied by 3 to the 4. These are both even, and it can be divided by 2, which tells me that I should have 2 squared multiplied by 3 squared, which means that it's 4 multiplied by 9, which gives me 6. So the square root, 1,296, is equal to 36. Okay? Pause the video, take a chance to try this for yourself. Determine the square root of 1,764. So 1,764 breaks down into 4 and 441. This breaks down into 2 multiplied by 2. 441 breaks down into 3, 147, 3, 49, 7 multiplied by 7. Now the nice thing about this is I don't even need to write out the prime factorization because I can see the groups right there. So then I know that the square root of 1764 is equal to 2 multiplied by 3 multiplied by 7. So 1 from each pair, don't forget that. So 6 multiplied by 7 to give me 42. Now that was perfect squares. We are going to move on to perfect cubes. So what are the first 10 numbers cubed? I would definitely recommend having at least to 6 cubed. 7 through 10 are ones that we're not going to use as much. So 3 cubed is a really good one to know. It's 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. That's as far as I personally have memorized. The farther you go, the more useful it is, obviously, because then you don't have to sit there and test with your calculator what you're doing. And then, of course, you should have all the powers of 10 memorized because it simply says, please have 3 zeros there. 1, 2, 3, so 10 cubed is 1,000. We have over here the parts of a radical. This is important to know. You need to know that this part is the radicand, the whole thing is the radical, this is the symbol, and this is the index. Okay? And we're determining the cube root of a whole number. The only thing that is different than determining the square root of a whole number is we're looking for groups of 3, not groups of 2. So 1,728 breaks down into 3, 576, which breaks down to 3, and 192, which breaks down to 3, and 64, which breaks down to 8, and 8, which breaks down into 2 cubed, and 2 cubed. And I know that because we just listed out the perfect cubes. So that makes it really easy, in fact, that I know I need one of these, one of these, and one of these. So then that says the cube root, the index, being 3 because I'm cube rooting it, 1728 is equal to 3 multiplied by 2 multiplied by 2, which is 6 multiplied by 2, which gives me 12. You always check the answer in your calculator. Pause the video. Try this one for yourself. So 2,744 breaks down to 7, 392, 7, 56, 7, and 8, which is 2 cubed. So circle, circle. The cube root of 2,744 is equal to 7 multiplied by 2 is equal to 14. Okay, last one, we have a word problem. A cube has a volume of 4,913 cubic inches. What is the surface area of the cube? So let's sketch out a diagram. Cube, volume, 4,913 inch cube. Now, if I'm trying to find the surface area, I need to find a side line, which means I need to cube root this guy. So, breaks down into 17. So I tested prime numbers until I got to 17. I didn't know it was 17. I didn't try 2. I tried 3, I didn't try 5, tried 7, kept going, kept going, kept going. That's why it's important to have those memorized. So then this changes to 289. And again, I tested and I tested until this worked. So we can easily see that the cube root of 4,913 should be 17. We need to check the calculator. So then when I do this, and I'm looking for surface area of a cube, I'm looking for length times width, or side squared, times 6. So 6 multiplied by 17 squared is 1,734 inches squared. And that's it. There's an assignment for you at the bottom, page 146. 4 to 6, odd. So all of 4 odd, 5 odd, 6 odd, 7, 8, 10, 14. If you have any questions, put it in the Google chat. If you have any concerns, let me know. If I made a mistake in the video, also let me know.